All right, so half of your exam is going to be tech active, which means you're going to have your calculator in front of you. If the question doesn't specify you must use algebraic methods, then you would be a bit silly not to use your calculator for all sorts of things. So I'm just going to run you through heaps of different things that you can do with your calculator. So the first thing is to be able to solve just a really basic equation, something like 2x plus 5 equals 7. Now, obviously, you can do this, but we're going to show you how to do it on your calculator. So we're in this mode here, run matrix. And then we're going to go, just ignore that for a second. We're going to go into the option menu. And then we're going to go into the calculation menu here. And we're going to use this thing here called solve n. Really, really useful, solve n. So I'll just click solve n, and then you put the equation you want to put into brackets. So 2x plus 5, and then it's shift, the equal sign's down here, 7. Close up the brackets. Now it might give you, it'll always give you this warning. It just says, look, we looked for answers, we found a bunch, or we found one, but there might be other ones. Just not really sure of itself. All right, here's our answer. 2x plus 5 equals 1. Let's just test it out. 2 times 1 plus 5 equals 7. Great, it's solved it. Now, for a lot of us, this is going to come in particularly useful when you've got a question like this. Solve for x, 1/2 equals sine 2x. A lot of us have trouble solving these trig equations. So if you have your calculator, why not solve n 1/2 shift equals sine bracket 2x, close up the bracket, close up the bracket. Now watch what happens here. More solutions may exist, exit. Okay, now look how many solutions they're offering us. Minus 31 over 12, minus 23 over 12, minus 19 over 11. So you're still going to have to give it some thought as to what solution actually makes sense for the question you're doing. The reason for that is because you remember periodic functions go on forever and ever and ever. You're solving, like you're essentially letting y equal 1/2, so you're going to end up with a lot of x values. So I know what you're thinking. I don't want to end up with a bunch of x values. I know that I want to solve x 1/2 equals sine 2x between 0 and 2 pi. Well, okay, you don't want to think. Let's just let our calculator do it. Option, calculate, solve n, and we're going to type in that equation again. Let's not do things too fast. Equals sine 2x. All right, now this is where the extra bit comes in. Comma. What's the thing I'm trying to solve for? I'm trying to find out what x is, so the variable x. Comma, the lower bound, 0, comma, the upper bound, 2 shift pi, and then close up the brackets. More solutions may exist. Boom. Here's our 4 answers that work for that particular equation. No thinking, you just got to make sure that you type in your equation, the variable you're looking for, 0 and 2 pi. Here's a sneaky one. If f of x equals 3x squared plus 5x, find f dash 4. So what we're doing here is 2 steps in one. We're finding the derivative of 3x squared plus 5x, and then we're subbing 4 in for x. You do this pretty regularly when you're doing like finding the tangents of things or finding the normals of things, if you think about the steps you follow for doing something like that. So how do we do it? Option, calc, ddx, type in your equation, 3x squared plus 5x. Give it a value for x, in this case 4, and it spits out 29. What that means is that the gradient of this equation at x equals 4 is 29, and you can use that gradient in your tangent type stuff. Now, a related idea to this is this one here. If f of x equals 4x squared plus 3, find the second derivative when x equals 2. So it might be like, here's the displacement function. Find the acceleration at time 2. So maybe it's a time function or something like this. That's a displacement acceleration type deal. So options, calc, second derivative. That's the second derivative, d squared dx squared. 4x squared plus 3. I'm using the wrong x there. Just got to make sure you're pressing this button for x. And x equals 2. Okay, so what does that mean? If this was a displacement function where instead of x we were using the letter t, so a function of time, this is our displacement function. Find the acceleration at time 2. I've done it all in one line, nailed it. All right, so here, what about like a definite integral between 3 and 1, 2x squared with respect to x? Option, calc, we've got this nice little integral here. And it's a little bit tough, but sort of arrow around until you find out where you need to be. 2x squared. That's it. 52 over 3. So that's the definite integral. Now that's not considering physical areas and things like that. That's just doing the calculation between 3 and 1 of 2x squared. So that's really as much as I want to go into in this particular page. We can take a look at the graphing mode of your calculator. All right, so let's just go back to our menu here. Menu, we're going to go into our graph mode, and it should look like this, y equals. If it doesn't look like y equals, if it looks like x equals or r equals or some other weird thing, just make sure you click on type here and choose y equals. Okay, I'm going to type in my function, 3x squared plus 5x minus 2, and I'm going to draw it. Let's take a look. All right, it's off the page. It's a bit of a pain. So a quick way to fix that is to click zoom, F2, and just aim for auto and see what happens. Okay, that looks pretty good. I can sort of arrow around a little bit just to sort of get a better feel for it. If I want to squeeze it in, probably you need to play with the view window, change your minimums and maximums, etc., etc. Change your Y minimum and maximum. Okay. So what do I want to find? I want to find the x-intercepts, the y-intercepts, and the turning point. So gsolve is your friend here. Gsolve, graphical solve. Roots are your x-intercepts. So just click root there. And it says x equals -2. Now you can see here it says execute show coordinates. Obviously the coordinates are not going to be exciting. It's just -2, 0. Now there's also more than one x-intercept, so you just arrow across to see the next one. And again, if I want to show the coordinates, I can just click that there. And you can see it's starting to get a bit messy. It's not really great. Okay, I'll just egg out of it. I'll just draw it again. That'll get rid of, oh no, wait. All right, we'll just leave that mess there. In any case, I found my x-intercepts. Let's look for our y-intercept. Gsolve, y-intercept. Okay, and it's spat out x equals 0, y equals -2. You can see there and there. So the y-intercept is -2. Now, obviously, I can press execute to make a real mess, but I'm not going to do that. And finally, it says find the turning point. So again, I can gsolve it. Maximum, minimum, y-intercept, intersect, we'll get to that later. Or y-calc, x-calc, we'll get to that later. We want the minimum. Now, obviously, it depends. If you're looking for a maximum, you're looking for a maximum. If you're looking for a minimum, you're looking for a minimum. That's our turning point, -0.833, -4.0833. So we found the x-intercept, we found the y-intercept, we found the turning point. Just for your own edification, if we go to gsolve and go to max here, it just can't find one. It won't just like jump to the edge. you might have thought that like it would just give you that value or that value. It just can't find one on the screen, so it doesn't tell you one. That's the basic idea. If you want to know the turning points, if you want to know the x-intercepts, if you want to know the y-intercepts, they've got to be on the screen. Okay, so now we have find the area enclosed between the functions f of x equals 3x squared plus 5x minus 2 and f of x equals 2x plus 4. Now I've already drawn that first one because that's the same as the one I was just doing. 2x plus 4. Now make sure they're both highlighted, otherwise they won't draw both. It'll draw both, and you can see we have this nice little intersect. I'm just going to zoom in a little bit. I just think that's probably a good idea. Now, wherever I put this little cursor before I click execute, that's where it'll zoom in around. Oh, that's really, really neat. Okay, now a couple of things you can do here. First of all, I can find out those intersection points, because that's useful if I'm going to do this algebraically. X equals -2, y equals 0, and I'm just arrowing across there, x equals 1, y equals 6. Okay, so I've got 2 intersection points. So if I'm going to now do a definite integral, I'd be doing the definite integral between 1 and -2. All right, but let's cheat. So draw that. Where's my little, oh, hang on. Draw it, G-solve, do. All right, integral. All right, and you can see that there's like a bunch of different versions of integrals here. Let's try a couple, see what they do. Oops, wrong one. Draw. All right, G-solve. I'm going to do an integral here. And I'm going to do the integral here where it says intersect. Let's see what that does. Intersect. Select lower limit value. So it's gone straight to the intersection point, which is what we want if we're doing the area enclosed. Click execute. And then it says select upper limit value. So I'll just like arrow across. And it'll take me over to the next point of intersection. And I'll hit execute there. Colors it in. Gives you the answer. Very nice. Now, just like once you've sketched something, once it's given you coordinates or whatever, and you want to get rid of them, there's probably a few different ways to do it, but the way that I do it is exit, deselect the graphs, reselect the graphs, draw it again, and it's gone now, and I can do whatever. Now, there are other versions of that integral. So if I click root, it'll to ask you which graph you're interested in. So I click that graph or that graph. I'm going to choose the yellow graph. And it'll then say, well, here's the first root, the first x-intercept. So yeah, I'll use that. And arrow across. Here's another x-intercept. Yeah, I'll use that. And then it'll just find the area, the integral of that function between that point and that point. So it's actually picked a function and then find the area between those roots enclosed by the x-axis and the function. So there's a lot of different ways that you can use that integral here. You can do it, the area between two curves. If you've just got a single curve selected, you can find the area between the x-axis and the curve. I'll just do one more. So I might just exit that. I might just get rid of the red line. So deselect that, draw. And then I might just do like a random amount of integration, if you know what I mean. So I might go like G-solve, and then just do this one here. And then it asks you for the lower limit, and I'll just type in, just start typing, just go -1, and then I might just go 1 for the upper limit. And it'll give you the integral there. Now, of course, you need to be careful because like that's a negative and that's a positive and they're kind of canceling each other out. So this is only if you're looking for a definite integral. If you're looking for a physical area, you might have to do something a bit different. Okay, there's a few different other things you can do with your calculator, but I think that's a really good start. That should put you in good shape for Unit 3.